Mic check. Good morning. How is everyone doing? Hopefully well. Felt weird. I got up this morning because, morning, Captain Price. Nice to see you. Thanks for being here. I felt weird because I got up to grade your class's assignments this morning and was reminded that you didn't have any. So hopefully that was a welcome break from this class. We got 3 more weeks, including a project. So hopefully you still got energy to sort of bring it home. Everyone's had such a good semester so far that hopefully we're just going to keep going and finish really strong. Okay, so we are on low-level control decisions. So what we're talking about here is what does an if statement look like to the processor? How does that actually work at the level of assembly language? Because it's not if statements, as it turns out. They do it by jumping around, literally using jump commands to jump around in the code. So to jump over things, to jump back to things, that's the looping part. But anyway, it's kind of neat. So hopefully you also sort of can see kind of how cool it is, and also it's a great way to practice your logic. So how do you set up your decision-making logic? This is a really good way to practice it, is to do it at the assembly level. Okay, so week 15, we'll go over this stuff, and then hopefully efficiently enough that I can also keep us going on project 2 and add one or two, work toward one or two additional features of that project. All right, but first let's walk through the week. So all of decision making on the x86 processor hinges on the compare instructions. So every time you need to make a decision, you need to perform an if-else type of statement. The first thing you have to do is fire off a comparison. Sometimes you have to fire off multiple comparisons, like if you were trying to get the behavior of a switch statement, let's say. You always start with a comparison, and then you start jumping places. So you compare and then you jump. We'll look at two kinds of jumps. The easiest one, but the one that you'll use it a lot. It's called the unconditional jump, which I'll show you first, and then we'll have conditional jumps, which are conditioned on the results of comparisons. And then finally, we will use statement labels, which is your textbook's term for it. Statement labels to give ourselves places to jump to. So we compare, and then we do conditional or unconditional jumps, and the statement labels give us the places that we jump to. If you've seen a go-to statement in a high-level language, that's kind of what this is. In high-level programming, a lot of people consider it a no-no to use a go-to, but in assembly, you have no option. That is the only way to do logic. And then we'll implement some low-level decision-making logic in a program. Okay, so that's the goal. So the readings are pretty focused these days. The reason why the integer arithmetic instruction is here is because I believe that's where the compare, if I remember correctly now, the compare instruction is introduced. Why is the compare instruction discussed in integer arithmetic? Because it turns out that comparison starts simply by subtracting one thing from another, and then it uses the result of that subtraction to know how to communicate to the programmer the result of basically how would they compare to each other. So for example, equivalent values, if you subtract one from the other, you're going to get 0, which is how that works. Okay, so that's the readings. The homework, as always, I actually had to make a couple of fixes, not to the answers, but I noticed a couple places I made a mistake in the code, so I don't think anybody had done it, but it shouldn't affect your work. The lab we'll come back to and give ourselves a start on. The Piazza discussion this week. is asking you to engage in sort of a gentle debate, or at least a discussion about high-level languages and their use of the go-to statement. So as a teacher, like in C++ as an example, I would always tell students never use a go-to statement. But that's just a personal opinion. As it turns out, some people don't think there's anything wrong with them. And as you'll see this week, the reality is on the processor, that is the only way to get something that looks like decision-making logic is with what are effectively go-to statements. So homework is always, lab is always, discussion is always, and then let's keep project 2 going so we can finish strong with that. Okay, so I'm going to switch over to my virtual machine here and start talking a little bit about, question, sorry. Oh, that's true. So Captain Price says they use go-to statements in batch scripting. I assume you mean scripting. And yeah, I mean, they are a legitimate means of controlling the flow of a program. So it's funny that we've gotten to the point in high-level programming where we say it's naughty to use them. It's really only, I don't teach them because I'm teaching usually new and less experienced programmers, but I think an experienced programmer should make the call themselves about when they're usable and when they're not. It can be a little scary because you don't have the structure of the code always with the go-to statement to tell you exactly what happens next. Okay, I'll come back to this lab, but let's explore the basics of decision making in x86 before we look at the actual lab code. So let me switch on the VirtualBox view and get logged in. And if that messed up, it did. Let me fix that. Okay, that's better. Okay, and let's just start with the basics, and then what I'm going to end up doing is splitting my screen and kind of side by side working on high-level decision-making and then assembly-style decision-making. But let's just start with the basics, so decisions. Actually, it goes in the right place. Feels like we've had time off, even though we haven't technically taken time off, since our normal routine wasn't interrupted. Okay. Before we do anything else, let's talk about labels, or statement labels, as your book calls them. So, switch this to HLA view so it looks nice. Okay, so let's talk about labels, and I just want you to notice immediately something about labels. Okay, so these are statement labels. So the first thing to notice is just how do you construct, or how do you put a statement label in your code. It's the same thing, probably Captain Price, this is how they look in batch scripting. It's an identifier followed by a colon. So that's a statement label. This is what they look like in code. It's an identifier. Meaning the same kind of word that you would use to describe a procedure or a variable in HLA, followed by a colon. So that's how you create a statement label. Now, the thing I'm about to show you is that statement labels in and of themselves do nothing. They don't do anything. All these do is mark locations in your code that you can then cause the code to jump to. But you can put labels all over the place, and if you run the program with labels all over it, nothing happens. So labels by themselves don't do anything. So it doesn't really harm anything to put them there. They really just become addresses or locations in the flow of your executable code that you can take advantage of. So let's do one. Let's use a label right here. So this is called an unconditional jump. It is not dependent on any condition. I didn't do any logic or any comparison of values or anything. I'm just jumping. It will. So Captain Price, you're exactly right. This jump right here, jump to label 2 means don't execute anything between here and label 2. So this says jump to this location in the executable code and then start executing from there. So I'm going to Okay, so this label right now does nothing. There's no instruction that jumps to it, so it basically just sits there. Now immediately I have an instruction which jumps to a label. Yeah, I think you will, Captain Price, especially if you've used them before, then it just feels so powerful. But also it's an interesting puzzle to solve, I would argue, to craft your decision-making logic with jump statements and labels. I think it looks cool in the code too, for whatever reason. Okay, so when this program begins executing, it flows right past the label because they don't actually do anything, hits this instruction that says jump to this statement label, so it does, and then carries on executing from there. So as it is right now, it's going to jump to label 2, and the program will immediately just execute. I get to go first, and this statement never ever happens. No. So good question. Captain Price asked, is there, as it's written, is anything ever going to take it back to label 1? And the answer is no. So as it is right now, there isn't a way to get back to it. So let's prove that and then see what happens if I jump backwards. So there's I get to go first, which is a consequence of jumping past 11, 12, 13, 14 to get to line 15 and begin executing from there. You can jump backwards. You probably don't try this one at home. But if I were to jump backwards, so if you jump backwards, you're making a loop. Now this is an unconditional jump, so this will jump backwards to label 1 and then begin executing from there, which will jump to label 2, which will print I get to go first, which will jump to label 1. So yeah, so what do we call that, Captain Price, or anybody else who's out there? What do we call it when we have this situation where we are stuck cycling through this same code forever? Infinite loop, outstanding. So this would create an infinite loop, so we got to be careful of those. But you can jump backwards, and that's how we make loops. That would be an infinite loop. Okay, so outstanding. That's just the basics. There's statement labels and then unconditional jumps. And by unconditional, we mean that they are not tied to any specific condition, which is, yeah, good one, Tyler. So this would cause this code to repeat forever, which we'd call an infinite loop. So good one. Okay, so let's do conditional jumps, and that's where we actually can craft actual decision-making logic. So I'm going to put this stuff, let me do a save as on it and start numbering them. Okay, so let's do something a little bit more realistic, but so you can see kind of the meaning of it. I'm going to do the high level logic next door. So high level. I wish that would have gone there by default. Put this into HLA mode. Okay, so I'll start by doing a high level setup, and then we will translate that into its low level form, which is how I recommend you do this, by the way. Start with a functional high level decision style, and then make a copy of your code, and then attempt to translate it into low level. So let's give ourselves a variable here, maybe 2. We'll just make this an uns8 for starters, and we'll give it a value. Let's make it 11. Okay, so what we want to do is say if x is greater than 10. I'm feeling funny because I guess I've been working in other languages. So if I make a mistake and you see it while I'm in the process, please let me know. So let's just start with that tiny little program. So we have this little one-off if statement. If our x is greater than 10, then we'll print out a message, and then no matter what happens, we're going to print out done. So let's translate that into assembly style. And again, this is how I recommend you do it. Get the thing working in the high level style and then translate it so that if you have to, you can always fall back on the high level style. Okay, so these all start with a compare instruction and then a jump. Sometimes a conditional jump. This one is going to be related to a conditional jump. And sometimes an unconditional jump, usually a combination of conditional and unconditional jumps. So a compare, CMP, followed by some combination of conditional and unconditional jumps to get to the code that you want to execute. The other thing to note is that I find that usually when I translate a high-level statement like this, the assembly logic ends up being sort of a little bit the opposite of the high-level logic. So in this case, we're saying if x is greater than 10, do something. And often I end up writing the assembly code to say if x is not greater than 10, don't do this. That's how I end up writing it. So jump only works on procedures or lines of code. Okay, so I think we can refine the question, or my answer is needed. You cannot jump from one procedure to another procedure using labels. So you cannot jump from the main body of a program to a procedure using a label. HLA won't allow it. So you can only make and use and jump to labels that are within a begin-end scope. And you can't jump across a begin-end block using jumps or labels. So I don't know if that answers the question, but hopefully it does. It's an excellent question. So the jump instructions and the labels only work within a begin-end block, and you can't jump across them using labels. So, yeah, so I think I answered that question, and it's an excellent question, Captain Price. You cannot jump from one procedure to another or from main to a procedure. So you can only use jumps inside of a begin-end block. Okay, so we're going to use a compare, a combination of conditional and unconditional jumps, and then I want you to note how often I work out the logic in the translation in a sort of opposite way. So usually what's going to happen here is instead of saying when do I want to print greater than 10 in assembly, it's often when do I not want to, interestingly enough. Okay, so let's do a compare. So we are asking x86 to compare x with 10. How does x compare with 10? And what it actually does is it says x subtracts 10 from x. We don't really need to worry about that. Kind of think of the x being the left hand of the comparison and the 10 being the right hand of the comparison. Okay, so usually this works out better to think to yourself, okay, in assembly, when would I not want to print that message? And I don't want to print that message if x is not greater than 10. So I'm going to do a conditional jump. The semantics, the way to read this is jump somewhere if x is below or equal to 10. So jump somewhere if x is below or equal to 10. When you're doing unsigned, the words that you use to describe the jump conditions are above and below. So I want to jump somewhere if x is below or equal to 10. The other thing to note here is that the jump has to happen immediately on the next line after the compare. You cannot do not do anything between the compare and the jump, or the flags are going to get broke. So you go straight from the compare to the jump that's conditioned on it. So if x is below or equal to 10, I need to go somewhere. I'm going to say don't print it. And then I'm going to make a label, don't print it. So again, the logic for me often works out better if I think of sort of doing this in the opposite way. The high-level language says only print this if x is greater than 10. So you need to sort of get in the habit of thinking don't print this if x is the opposite of this, which is less than or equal to, or in x86, below or equal to 10. So if it's below 10, I don't want to print this. If it's equal to 10, I don't want to print this. And that is jump below or equal to, don't print it. Now the trick is to understand what happens if it is the opposite of below or equal, which is above 10. Well, then I do want to print it. So if I don't do that jump, then I do want to do the print. I usually use a little bit of tabbing just to kind of make it look like ifs. And then the very last thing of this program is this done statement. So there's the same program translated. Let me see if I can push it around a little bit. So that should be on line 18. This should be on line 16. Okay, so that's how I would translate it, sort of for the minimal effort. So I had to think of what's the opposite of this. What's the other condition that this is not using, and the other condition is, oh, x is less than or equal to. If it's not greater than 10, then it must be less than or equal to, and it's the less than or below and equal to that's actually important in terms of doing the logic, because I don't want to print this if x is below or equal to 10. So that does take some experience doing logic, which you all have a lot of experience doing logic. And hopefully that made sense what I did. I should call this low level. So that it's obvious. So that's that code translated across. I'll show you a couple of other tricks. Some people put their labels in all capital letters, and that's perfectly acceptable in terms of the rules. And it makes your labels easier to find. The other thing that I personally do as a style thing is I butt my labels up against the left margin, just because I personally find it easier to find them. Some people will also like put underscores all around it just to make them pop out even more. So one of the nasty things about this style of programming is that you can end up with a lot of labels, and they can be difficult to find in code. So if you need to use these little naming tricks to make them easier to see, don't hesitate to do that. Right? You can do things like put double underscores in here if that makes it easier for you. You just have to make sure that if you do that, make sure that it matches everywhere. So whatever tricks you need to make your labels pop, it's recommended that you do that so that the labels stand out. I personally just put them in all caps and use snake casing to make them pop. That's all I need, plus I put the labels off to the left so that I can see them. All right, so there's example one, a simple if statement. Let's do something harder. So I'm going to move this out of the way. Do I want to move the whole? No, I don't. I don't want to move the whole program. I just want to get this thing out of the way. Is there a... I'll just comment it out. It's going to get to be harder. I don't know if this editor has a global comment them out feature or not, although I am going to show the continuity here. I have to hit the delete key. Okay, that's better. Okay, let's do a harder one. Okay, so signed integers use above, below semantics is the fancy word for it. But just think when you need to describe your conditions with signed integers, it's above or below. So now let's do a y, and let's make it signed instead. And then let's do a slightly more elaborate decision tree. So if y less than 0, and so let's translate this one. So this is signed, which is why it can be less than 0, right? Let's give ourselves signed. So if you're doing signed comparisons, then the way to describe your jump semantics, your jump condition is greater than, less than. And because you've done 2's complement and you know how these values are represented, it's important that the processor know if the comparison was between signed numbers or not signed numbers, when it does the math on them, so that the condition setting, the flags that result are correct. So if you're comparing signed numbers, hint, hint, this is important on project 2. If you're doing signed numbers, then you have to describe your conditions using the terms greater than or less than. If you're comparing unsigned things, it's above, below, so it's different jump instructions. If it's signed things, it's greater than, less than. It's a little bit funky, but so it goes. Okay, so if x is less than, or y less than 0, so we're going to compare y with 0. Yeah, so the question is, what is semantics? That really just means the words we use to describe something. So when you hear me say semantics, I just mean really what are the words that I'm using to describe the situation. So the semantics, the words used to describe conditional jumps with unsigned integers, the words used to describe those jumps, or the semantics of those jumps, are above, below. When the values are signed, then the words that we use to describe those jumps, the semantics, are greater than or less than. So semantics is just a fancy term for the words that I'm using to describe that situation. So hopefully that makes some kind of sense. It really just, that's all I mean though. When I say the semantics of signed integer comparisons, I just mean what words are associated, greater than, less. And then the semantics of unsigned are the words that are associated with the conditionals for that are above and below. So hopefully that helps. That's just me using a fancy word, but you'll hear programmers use semantics sometimes, which is really just what words do we use to express the situation. Okay, so we're going to compare y and 0. So it's very, very important that we use, and I'm glad you asked, Ursabak, because now I can sort of abuse that word because it's how I would describe it, actually. So here again, the weird thing about this, now if you have more than one condition, you can work this out, but often things are sort of opposite the way that you might. Okay, so we're going to jump if. So usually for me, it's working out when I don't want to do this first. And when I don't want to do this is everything that y is not less than 0. So that would be y is greater than 0 or equal to. Good one, Captain Price, you got it. So notice that my jump instruction uses the greater, less semantics. Because I'm doing a signed integer in that comparison. Yeah, I was pretty sure that was a J, Captain Price. So yeah, you're dead on. So jump greater than or equal to negative. So now I have negative, in which case I'm just going to copy this. Okay, so the trick here is to sort of think about what happens if why would we not jump? When would we not jump here? What about y would cause the jump to not happen? When y is greater than 0 or equal to. So if it were greater than or equal to 0, we won't jump, and that's when we want to do this one. So they end up sort of coming out backwards. At least for me, this is the way that I usually get it to work out fancier. Okay, so if y is greater than or equal to 0, then we're going to say, did I do these correct? Greater than or equal to 0. y is positive. No. Yeah, I did these backwards. Didn't I do these backwards? Negative. Yeah, I made y be negative 1. So if y is greater than or equal to 0, then it's positive. Yep. And then, so I got the statements to come out in the right order. So if it's less than, then I won't jump and I'll print out the negative if y is less than 0. Yeah, that was a terrible logic mistake. All right, so here's the trick. There's one more step here. And remember when I said very often you have to use a combination of conditional jump instructions and unconditional instructions. So if I run this program right now with negative 1, it's going to say y is negative, and then the program's going to keep flowing, and the thing to remember is that labels don't actually do anything. So if, as it is right now, the program will not jump. It will say y is negative, and then flow, 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 and then print y as positive again. So somehow, after I print this, I need to not let this one happen. That's right. So here, we need, we can do an unconditional jump so that we don't do this part. So we'll put the end so that we don't do the negative part. Yeah, so exactly right, Tyler. So I think you're all sort of getting the idea. They look really funny, but if you're not careful about getting out, so the trick about an if-else statement is that once it finds a winner, it jumps off to the end. So once you find a winner, you need to get to the end, or the program will happily flow through all the labels and print out a big mess. So that's how I might translate this if-else if statement. So here's the unconditional jump, because once I've done the y is negative, there's no other conditions to test, but I need to make sure that nothing else happens. So pretty wild. It's okay, by the way, to sort of clump these up. I didn't know if that would help or hurt, so I separated them out a little bit. Although maybe this is smart because it looks like a one whole statement. There's something else, by the way. You cannot repeat labels. You can't have the same label in the same section. In fact, I think maybe anywhere in the program. So you got to be careful about your labeling. I mean, you might even like number them just to be on the safe side. So be on the lookout for that. I usually don't number my labels. I just, occasionally I guess I do number the labels. But make sure that you're not using, you can jump to the same label twice, but you can't have, this would be bad. You can't do this. And if you think about it, how could you do that? Where does it jump to? This one or this one? So it's just not allowed. Don't duplicate labels. Okay, so not too terrible, but you can see how this can get pretty hairy if you get a big decision tree. Yeah, so the program won't crash, it won't compile. So if you duplicate a label, the compiler will catch it, thankfully, but you'll get a compiler error if you duplicate a label. Now if you jump to the same thing twice, that's okay, but it's having the actual label statement, the statement label twice. You can jump to it twice, that's fine, but you can't have the actual statement label itself duplicated, or you will get a compiler error. Okay, so let's do the nastiest of the nasty ones. Checking time. Let's do the full-on if else if, and see what that looks like. Yep, exactly right, Captain Price. What do we want to do with this one? Let's do some kind of a, I'll use a, no, because you can have negative temperatures, so let's do like an N16, doesn't really matter. And let's say, like a temperature, let's say 212. So we'll do a little temperature decision. Yeah, 98.6, except for we haven't done reals, floats yet. So that'll come up in the last week of class, but right now we still only have integers. Yeah, exactly right, Captain Price. It's a float. Okay, so let's do a if z is less than or equal to 32, then it is cold. Else if z is less than or equal to, let's say, 70, then it is cool. Else if z is less than or equal to 90. I don't want to do too many of these because they're just kind of already made our point. Is warm. So if z is less than or equal to, let's say 110. Hot. We'll do an equals in here. I just want you to see a sort of a more elaborate decision tree. We should say greater than or equal to. Getting some typing fatigue here. And we'll just do they didn't tell me what to do with that one. So that we have an else. Okay, that's a lot. It's going to be a little bit hairy. But I want you to see one where you have to make a whole bunch of decisions. Whole bunch of decisions. So z, which is an N16, 212, we'll make it boil. Signed. So remember that the semantics is greater than, less than. So yeah, that's true. This is a lot of comparisons, and it's just a fact of life. Now, there are other ways to do it than the way that I do it. There's, as many of us as there are, we'll come up with different ways to do it. I'm just going to show you the way that I do it. So, for big, scary ones like this, I actually do try a little bit harder to not flip things around. I try to have them flow in the same way. So, I'm going to do z and 32. And then I'm actually going to have my jumps sort of jump down, jump down to each new section. So the way I would get to this next test is if z is greater than, and I usually do something like this, so try 70. There's my label. So if I don't jump here to the try 70, that means that it was less than or equal, less than or equal to 32, and I can say it's cold. So for these bigger trees, I actually do try to make it look the same, because I can keep up with it in my head a lot better. So remember here though, the critical thing is every one of these little subsections has to pop out. So every one of these, pretty much until the last one, has to pop out of here. Okay, so there's, is z less than or equal to 32? If not, then I'll try 70. So I run the comparison again, this time against 70. Same thing. So if I'm not less than or equal to 70, in other words, if I'm greater than 70, then I will try 90. If I don't try 90, then I will grab it as cool and pop out of here. So hopefully you can kind of see how I'm structuring this. Here's my try 90. Do another comparison with 90. If I'm not less than or equal to, I must be greater than, so I will try 110. Otherwise, I can print warm and pop out of here. So these aren't too bad with a little bit of practice. Hopefully you're getting the idea. I'll go ahead and finish the thought. It's more code, but notice how you have to repeat the comparison for every condition, and then make sure that the jump happens immediately after the comparison or you lose the meaning of. Yeah, so it should be greater than because I want less than or equal to. So if it's less than or equal to, I don't want to jump. So it's only greater than that I'm going to skip. I'm going to try 110. Jump greater than 110 to try 212. Let's see, 110 as it is getting hot. Then get out of here. Try 212. So the nice thing for me anyway is this all, oh, and by the way, there's no harm in putting a try 32 label, even though you're not using it. There's no harm in using a label to sort of make your tree seem clear, right? So this first section is try 32. I don't actually use the label, but I can put it there so that it reminds me of how the sections are put together. So perfectly fine to do that. 212. Okay, so here we go to greater than or equal to. So what we're interested now is anything that's less than that is all the other stuff. So it's the greater than or equal to that we want. So the only other possibility is less than, which I'll just make myself an else part. And then I have my else part where I have cannot describe. There's no harm in putting a jump here, by the way, but you don't need it on the last one because that's where it was going to flow to anyway. So you can get rid of the jump on the last section because you were going to end up there anyway. So there's that whole tree set up in assembly. I happen to like this. You can use whatever names for your labels you want. This one just makes sense to me. Anyway, so there it is. It's more code, so 12 to 39. So 20 lines of code versus 10, a little over 10 lines of code. The only way to know for sure, by the way, that these are working is to test them, unfortunately. That's the only way to know for sure, is to subject them to some testing, try out different values to make sure that all the pieces trigger as expected. It's way easier to test if you put it inside of a loop. Okay, so that's that. I'm going to go grab the lab code and see if there's anything scary looking in it. And maybe I'll just give you one example. So your challenge in the lab is going to be to, first I recommend that you compile it and run it and see how it works without you touching it. And then you begin to translate the if statements and try to preserve, obviously, the same behavior. Yeah, good point. Compile the code and try it out. Okay, so let me go grab the lab code and let's look at it. You have been seeing all that, aren't you? Yeah. So I'm not going to change my view, but I am going to go grab the lab code and I'm going to plug it into the editor and let's look at what it's asking us to do. Can I make a new? Sure, whatever. Yes, that's what I want. Okay, so let's see what the lab's asking us to do here. This is lab 15, by the way. This one and two others. So this has 7, I think. 7. Yeah, so it has 7 ifs that have to be translated. So let me show you how I would do it. By the way, one of them's already been done. So notice inside of the get int 8 procedure, one of them's already been done. Hint, hint. This procedure should go in your project too. Exactly as it is. It's already got the translated high level logic into low level. But here I've translated the high level logic, the break if stuff, into low level logic. Except for the loop, right? I left the loop, we're doing that next week. But here's the break if translated into low level logic. That one's already done. Okay, so here's number 1. And it's got number 2 inside of it. So probably what I would do is get the ones on the inside first. But I'm going to go ahead and do the one on the outside, and let's just see how that works. So here's how I would do it. Now the catch is that once you start translating, you're going to have to translate the whole thing. So this is, do I have time to do this? I do. This has if else 1, else if else 2, else if else 3, else. So it's got 4 things in it. So let's start translating it. The way I would do this is I start commenting them out. So compare AL and 1. Since these are all positive numbers, I can use unsigned comparisons. And I'm going to use the same strategy I just used. So jump not equal. Oh, I forgot to give you a list of that. I'll do that real quick. Jump not equal. I'm going to call this my menu try 2. The reason I put the word menu on here is because I know I'm responding to a menu choice. And I have a feeling that I'm going to have other places where I'm using this try. So this is my try 2 for the menu option. Oh yeah, good point, Captain Price. So look in Piazza. I'll go put a note about the jumps. You'll also encounter them in the book, but I'll put a note in there for the jumps. Okay, so here's the things to watch out for. So there I did the if AL equals 1, replace it with a comparison and a conditional jump. If AL is not equal to 1, JNE, then I will go to menu try 2, which is right here. Now here's the trick. Don't forget, this is the AL equals 1 part, and you got to get yourself out of here at the end. And notice how I put the word menu on the front because this is sort of my menu tree. So I'm going to go way down here to where this end if is. It's right here. Replace that with a label. So this is a pain. It's a pain. and you have to be careful. So there's the compare that got me in there. There's the jump at the end. Here's try 2. 2. If that's not equal to 2, then I will menu try 3. That's this next one. And then make sure that when I get to the end of this section, I jump to the menu end label. Here is menu try 3. And then I'm going to have my else part. And then I'm being careful to make sure that inside of each section I jump to the very end. And then here is my menu else. There's no comparison to do on that. That's just the else part, which will flow down, 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 and I don't need to jump because it will just flow into the end. So that's actually the hardest one to do, and I think that's complete. I went kind of fast because we're running a little short on time, and I want to give you a reminder about the project. Okay, so that's your challenge. What I recommend you do one at a time. So get it to compile, run the program to see what it's supposed to do, and then translate one piece, compile it, get it to do what it's supposed to do. Worst comes to worst, if you don't translate all of them, then you just take a deduction for the ones you didn't translate. It's not that big a deal. But anyway, I recommend that you translate one at a time, and then after you translate that one, compile it, run the program, make sure that it still does what it's supposed to do there. This one's relatively easy, so you can just do that one right inside of there. This one's pretty similar. Let's see, number 4. Thankfully, that one's the easiest one of all because it's just an if. And then number 5 has an outer and an inner also. So be careful, number 5 has an outer and an inner. And then finally number 7. Yes, so good question, Captain Price. The lab is already complete. The code works. So when you get it, compile it and run it just so you understand what it's supposed to be doing before you start translating. So yes, it works with all high-level decision making, and then your challenge is to remove all of the if statements and replace them with the assembly style. It's a good programming puzzle. So anyway, if you're watching the video later, remember that I did the number 1. It's untested, but I'm pretty confident I probably did it right. Hopefully I did it right. And then before I do my last sort of quick look, I will make a note and put the sort of the jump semantics stuff in a Piazza post. Why are they worth 100 points apiece? Just to keep the math simple. So the question is why are all of the assignments the same weight? And I don't know, I figured for the discussions, it's just kind of a reward for people to stay involved and engaged and actually make that contribution every week. And then for the labs and the homeworks, that's because I consider them sort of equally important. That you sort of get the book learning part down, that you walk away with the book knowledge. And then we reinforce that with the programming exercises. So I roughly consider them, all of them, of equal importance. The discussion is sort of staying involved and engaged. And then the labs and the homework assignments reinforce each other in terms of the book knowledge and the programming techniques. Okay, so yeah, we all have our different styles. I'm getting to be old, so maybe I've gone soft a little bit. Let me open up the project real quick. And why is lab 15 in the wrong place? Because I put it there. Project 2. computer. That's in my spreadsheet program, is it? Oh no, that's the whole on. I've already done it. I want to just remind you about where we should be. Where's project 2? Maybe I called it sheet. I did. Just to remind you about what you should be doing for project 2, because we're these gets, so we just had a new and improved get in 8, but the get in 16 and get in 32, you have them out there. You have an edit cell routine. We did a min routine, which means that you can do a max, and I recommend that you implement the entire spreadsheet with high level code, and then you can decide if the points for doing the low level translations are worth it to you on the project. Show binary we have from earlier in the semester. Hopefully someone will hunt that down and remind us where that came from. So I am going to show you one thing, and I'm going to run over 5 or 10 minutes. So hopefully if you have time, thanks for sticking around. If you don't, then the last 5 to 10 minutes of the video is project 2 stuff. So let me just talk a little bit about the display format. So one thing that project 2 is supposed to do is allow the user to toggle the display between decimal, hexadecimal, and binary. So you're going to need a format variable that tells you which format should I be in. Now I'm going to use an UNS8 because to me that I'm just going to use like number 1 means decimal, number 2, you know, that kind of thing. But you need a static variable for the format, and if it were me, I would just default it. We'll say that that if this value is 1, then we're in decimal mode. Let me just show you how I would use that on the project. So we have this variable, and your user is going to need a menu option to toggle it. But when we go to print, this is the same sheet I worked on last week. We have this forever loop. When we go to print the array, add the format flag. To this print procedure, and then I'll show you how to use it. So we're going to add the format flag to our print procedure, which means we need, I'm just going to call it lazily F UNS8, and then here's how I would use it. So if F equals 1, then in fact, so this is how you can sort of fancy up your output of your spreadsheet to show them what data format they're looking at right now. That F is 1 means decimal. I totally made it up. That F is 2 means binary. I'm just making that code up. Just like we've been doing the codes for the data type, this is just a code that tells me what format. Binary. Something feels wrong. No, I guess it's right. Shouldn't ever get to be anything other than. So this just tells your user, I'm showing you decimal or binary right now, which is just a way to make your output a little bit fancier. So now we have this F, which is the format flag or format code. 1 is decimal because I said it is. You can make it be 47 if you want. It doesn't really matter. You just need to make sure that you know what your codes are. So for me, code 1 is decimal. Code 2 will be binary. And then the other code will be hex, which technically will be code 3. So here's the other thing. When you're actually doing the outputs, you need to be. So here's how I'm going to do it. I'm going to change this to be a print int 8, and I'm going to pass the data along and the format. And then I'm going to make another procedure for print int 16, where I'm going to pass the data along and the format, and then I'll make another procedure for myself called print int 32, pass the format along. Okay, now technically these now go. So I'm going to make procedures that then figure out which format to use. So print in 8 as an example. That's going to come in as a value, which is an int 8, and a format, which is an uns8. This is just one idea. You don't have to do it this way. I just thought this might be helpful to you to figure out how is my sample program actually swapping out the formats. This is how I did it. So as I'm looping, as I'm doing my this print, where I show the format, oh, you're about to see stuff in decimal or binary or hex, and then I actually loop. Oh, I'm going to need that down here as well, by the way. That also goes. I made little procedures to make this a little bit easier to manage. So in here, why not protect our register? So now I'll just say if f equals 1, then does it need a space after? I think it does need a space after it. Hexadecimal. If I want hex, I put it in a register. And then I'll use my show binary that's going to need to be updated. But anyway, closing in on about 10 minutes over. I highly recommend this approach because it partitions your code nicely. So your print function, the big print function, it doesn't actually know how to print the data. All it does is it passes the data with the desired format to a function for the different data types, print in 8, print 16, print in 32, and then those procedures figure out what format to use. We have a show binary procedure. You may need to, you may want to make yourself like a binary 8-bit function and a binary 16-bit function just to keep those things separate. Anyway, this is how I achieved my outputs in my sample implementation that you can download and execute, play around with. That's how I did it. So that's anyway where I'll leave it. I may add some implementation to this just so when we come back next week I will have some of that working. Anyway, so that whole thing was about how do I actually toggle between decimal, binary, and hexadecimal. Well, now you see. I added a static variable, which is just a code that I have in my head, M format, where I know in my program I'm going to make sure that when I want decimal it's 1, when I want binary it's 2, and when I want hex it's 3. So then when I call my print function, way down here in main, I pass that format code, and then I use that format code in my print function. First, just to make my main display look pretty. Oh, you're looking at decimal right now, or hex, or whatever. And then I also pass that format along to my specialized printing function, which then figures out specifically what to make it look like. Sorry, I'm wiggling that around quite hard. So anyway, maybe that leaves you with that sort of smaller part of the bigger project that you perhaps can work on. So what I need to do is I need to adapt my show binary procedure from earlier in the semester. And maybe if you find it, by the way, you can put it in Piazza, or at least tell us where you found it in Piazza. I'll adapt my show binary procedure to spit out this value in binary. Okay, got to stop. I'm using up enough of your day. So thanks for being here as always. Thanks for engaging with me. Hopefully you're possibly. Yes. Captain Price saved the day. That is a terrible bug. Value, thank you. Line 65 should be moved value, not F. F is just the formatting code, so thank you. Good, terrific catch. Oh, Tyler. Sorry, it was Tyler. So I was just glancing over there. Tyler, good catch. Thank you. Appreciate it. Line 65 is move value. Thank you. That was going to cause a lot of us a lot of headache. Okay. Very much appreciated. Just want to glance to the side. I wasn't careful about seeing who put that comment. So thank you, Tyler. Very much appreciated for the fix. I will save. So anyway, have a great day. Have a great week. Hopefully this gives you things to work on. You are more than welcome to either bring questions. So next week is our last meeting before your deadline for Project 2 happens. So load up as much as you want. The content next week is how do you translate loops into assembly. But you're going to find that comes to you pretty easy after you practice a little bit on decisions. Loops in assembly is just jumping backwards. In many cases is all that is. So, thanks again. Thank you, Tyler, for the fix. Thanks for being here, everybody. Have a great week. Anyway, please let me know by Canvas inbox or let us know in a question in Piazza if you need tips. If you're doing a good job of farming up procedures, it's fine to share those in Piazza because we already have those procedures. Or at least maybe leave a note in Piazza about where you found them so that the rest of us can farm them up for our project. Okay, anyway, I may go a little bit longer than normal next week just to make sure that we're all in a great place to have a strong finish on Project 2. Okay, I'm done. So I will see everybody next week.